Now we look at what we could almost call the last thing, okay? And we'll be done, okay? And this is going to have, what number is this? What number is this? 5? Okay, so 6 would be reaction with metals, okay? Reaction with anything to do with metals, okay? Reaction with metals, etc. Okay, etc. Anything to do with metals. Now, basically, when an alcohol is reacting with the metal, that's where you see that it's a little bit of an acid. Okay, it's slightly an acid, so it behaves the same way that your acid would behave. So we know that acid plus metal is equal to salt plus hydrogen. So if I have my 2R, let's have it as the ROH, okay, is the ROH. Now, what's going to happen is if you mix this with a metal, okay, 2K, this is a metal, potassium, okay, so acid, let's have it as an alcohol plus metal, this gives me salt and hydrogen. It's like acid plus metal is equal to salt plus hydrogen. So this H goes away. So what we are going to have, it becomes an RO, and then what happens? It's an O minus K plus, which is a salt. And then as a byproduct, you have your hydrogen. Remember that. And this salt is called an alkoxide. So it's called an alkoxide. An alkoxide is something that has a negative oxygen, or minus. Okay? And this plus makes us call it a potassium alkoxide because it's from potassium. Now, the second reaction here is going to be again your acid, to RO, then put a dash H. Then this guy, it is now reacting with another, let's have it as a metal hydride. That's the only one, the second one. Say NaH or KH, okay? This is going to be the same. So this K could have been an Na. Remember that. And you just have here, instead of K plus, you'd have it as an Na plus, right? Now I have it as an NaH, the metal hydride. What's going to change in here is that we don't need to put 2 moles each. It's going to be just one more. So in here, it'll be what? ROH plus NaH. And it's going to give me acid plus metal hydride is the same thing, salt plus hydrogen. So it's going to be R, then O minus Na plus, then hydrogen. So only thing is, this time I didn't need 2 moles of anything. And that is it. You have it. Salt plus hydrogen. And what's your salt? Sodium alkoxide. Okay? It's sodium alkoxide. That's my salt. Okay? And what is it? It has plus hydrogen. You are done. Now, this is the same thing that happens if you had it as a phenol. So here is for your phenol. It's the same thing. Okay? Your benzene. So I could have anything like this. Like this. And you have an OH. So the moment I see this OH, I know, oh, it's a phenol. It's going to behave like an alcohol. What happens if I add a metal? So I'll add 2 moles of sodium. Then this just becomes a salt plus hydrogen. So I will get 2 moles of this guy. 1, 2, 3, 4. He's going to be like this. And here I have a salt. So it becomes Na. It becomes O minus, then Na plus. Okay. Then what would it have? Hydrogen, H2. Okay. Then what is the last one? What about if I have the same thing using those things? So 1, 2, 3, 4, then 5, 6. This guy, this thing here, what would happen if it now reacts instead of a salt? What if it now reacts with a base? Like NaOH. Acid plus base is equal to salt plus water. So we can know it. It's a neutralization reaction. We saw that acid plus metal is salt plus hydrogen. Acid plus base is salt plus water. So you have it like this. And here you now have your ONA. Okay. And what would you have as your byproduct? Water, H2O. And here is your, again, this is now called sodium phenoxide. It's from a phenol. It's sodium phenoxide. And that is what you have. And that is it for for alcohol plus metal. It reacts as an acid. Don't ever miss it. You can kill it. Here, acid plus base, salt. What is salt? Something with a minus and a plus. So O minus and A plus. That's your salt. Okay. in something, let's say something with a non-metal and a metal, okay? You can just see them, write it as an ONA, then plus H2O, and you'll be done. Okay, now the last thing which you'd have to know is about reaction, let's say combustion. Okay, combustion of alcohols. Alcohols can be used as a fuel, especially ethanol. It can react. And what do you get? Complete combustion always gives us carbon dioxide. Okay, so here and water. So it's like I have my CH3OH. What is this? Methanol reacting with oxygen. Combustion is when you react with oxygen. And in here, what do we get? Carbon dioxide plus water. Okay. And then, of course, plus energy. And when we balance it, here you have a 2 and here you have a 4. So it's a 2, 3, 2, 4. Reaction, combustion of alcohols, you get carbon dioxide plus water. And then, of course, some energy as byproduct. And that's you have. Now, the last thing which I'll do before we call it quits, is called the breathalyzer. It's called the breathalyzer test. Now, we've seen that when you oxidize alcohols, if it's a primary, it goes to a carboxylic acid, first via an aldehyde, then all the way to carboxylic acid. If it's secondary, it just makes a ketone. Now, and we saw our reducing, our oxidizing agents, KMnO4, then K2Cr2O7, okay, Cr2O7, and then another one which we saw was Na2Cr2O7, right? We had these as our oxidizing agents. Now, what did we see? We saw that when I'm using this, okay, now what I want you to know is that either one of them, right? We saw that either one of them works. Now, what I want you to know is we're going to take this special guy, either the K2Cr2O7 or Na2Cr2O7, but we'll just take the ion, the Cr2O7, and it's going to react. So this breathalyzer test uses this Cr2O7 guy, which is in the acid, because he's going to be reduced. So what happens is you have an acid H+, then you have this Cr2O7, okay, and it's a 2-. Now, and you react him with C2H5OH. What is this? Alcohol. So alcohol meeting the Cr2O7, what does it do? This guy goes from being orange, so he is orange, Cr2O7, he is orange, but when he reacts with an alcohol, he's going to be reduced to be a chromium 3+, which you write as a Cr3+, okay? And then plus this alcohol becomes an acid, so it will be CH or C2H, or let's say CH3, then COOH, okay? Then plus water. So that is what we are going to have. That's the last thing to know. You have an acid, some type of acid. It's acid. So this reaction we acidified. Then you have your Cr2O7 meeting an alcohol. It changes to Cr3, which is green. Okay, Cr3+. Okay, this is going to be chromium 3 ion. Okay, is the chromium. It is the chromium 3 ion. Okay, chromium 3 ion. And in here we have the acetic acid. Well, it doesn't matter what happens. Here we know we are coming from ethanol. Okay, this test is used to check if you're drunk. Ethanol is the beer that it's there in every alcoholic juice. So what happens is if it meets this K2Cr2O7, just know that this this was a Cr6+. It is going to change to a 3+. So it has been reduced. Okay, whilst it has oxidized this ethanol all the way to give you a carboxylic acid, CH3COOH, right? And release water. So that's what's going to happen. And that's the breathalyzer test. What do you have? Cr2O7 meeting the ethanol and should be acidified. Then what are you going to have? This Cr becomes a Cr3+. When it was a Cr6+, it becomes Cr3+. Then you have acetic acid and water. All that are things that are removed. So this leads you to the breathalyzer test, which checks the presence of an alcohol. And here you are done. That's going to be the end of alcohols.